slide here, which is in your notes. Yeah, I suggest taking some notes here because some of these questions that we're going to look at today are kind of hard. Some of them aren't too bad, but some of them are kind of hard. So when we're dealing with permutations, we're going to use this new notation that we haven't seen before. It looks like this, NPR. Okay, I really want everybody to be paying attention right now so I don't have to answer questions like, what does NPR mean later? Okay, I would like everybody to know. So please pay attention. Okay, NPR, and you'll notice the way it's written. You should write it the exact way it's written here in these notes. The N should be small, the P should be capital and bigger, and the R should be small. Okay, they're called subscripts. Okay, you should be using them. They should look the same. They are not exponents. Okay, exponents are a pi, right? They look different. Okay, now this represents the number of permutations that can be made from a set of n different objects when only r of them are used in each arrangement. Now that sounds really complicated, but it's what we were just looking at. So when we were looking at these positions, and there were 5 positions, but you were only voting on 3 of them, okay, we were talking about that in that question that you just had. Okay, the way we would write it is we would say, well, there were 5 positions, and we were picking 3 of them. Okay, and that is what it means. It means that there were 5, but we are only going to use 3. Okay, that's how this notation works. So it's not super complicated. And that's exactly what it should look like, the way I have it written there. Okay, now, when we're talking about it, just like using our voices to talk about it, generally speaking, people say what I just said, 5 pick 3. Okay, that the P, people say pick. Okay, it stands for permutation, really, but people just use the word pick to kind of talk about it in a comfortable way. So 5 pick 3, I have 5 things, I'm picking 3 of them. Okay, I have 5 different student council positions, but I'm only picking 3. Okay, or if I have, and that's exactly the example that's given there too, I guess I didn't need to write down, but you can see it in typing as well. It looks exactly the same, it looks beautiful. Okay, now the official formula is very similar to what Natalie came up with, but it's more mathy looking. There's less words in it, but it's the same formula. So on top, you always put the total that you're picking from, and then here, the n minus r, even though it's a little more complicated looking, it makes sense, right, that if we're picking 3 positions, there's 2 left, because 5 minus 3 is 2. So when we actually do it here, the way we would do it if we were 5 pick 3 is if I was using the equation, I would write 5 over 5 minus 3, and I would get, okay, well that's 5 over 2. Okay, and I'd be able to do that. Tricia, you have a question?
Give this to a student in grade 10 who hasn't got one yet.
Okay, sure. Yeah, thanks. I'll pick someone worthy.
Yes,
I'm
sure you will.
My favorite grade 10. You'll know who it is based on who has that calculator tomorrow. Okay, so that's how it works. It's pretty easy. Okay, Matt has downloaded 10 new songs from iTunes. He wants to create a playlist using 6 of these songs arranged in any order. How many different 6-song playlists can be created from his new downloaded songs? Okay, now I don't want to get too ahead of myself, but in this unit we're going to look at 2 different things. Okay, we're going to spend a bit of time first looking at these, which are permutations, and then we're going to start looking at something that's very similar called combinations. The main difference is that permutations, we're talking about the order mattering. So here, if we're making a playlist, we're assuming he cares what order the songs can go in. Okay, so it's going to be different. Like if he picks the same 6 songs, but he plays them in a different order, it's going to be considered a new playlist. Okay, so he's not putting this thing on shuffle. He is playing it in the order that he's planning it. Okay, so here, I'm just going to try to use that notation. So remember that notation is N, P, R. So in this example, what value would I put in for N? 10. So the first value a lot of the time when students are having trouble with this, it's just because they've mixed up the order the numbers should go in. The first number, the n, always has to be the higher number, because we're saying this is how many we have to choose from here. We have 10 songs to pick from. Then we put the p, okay, and then next we put 6, because that's how many we're choosing. Now, if I made my equation, if I made the equation for it, I'd put the total on top, and on the bottom, I would put 10 minus 6. Now, if you wanted to, if you were like feeling like a brainiac, okay, you could make this process go a little bit faster and do that 10 minus 6 in your head. What's 10 minus 6? 4, and just have 4 right away. You could do that. So this is going to look like 10 factorial over 4 factorial. And if I wanted to do that out, right, what would that simplify to? Instead of having to do a top and a bottom, what would I end up with if I multiplied it all out and canceled what could cancel? What would be left over? Okay, so if I got it down to that line of just multiplication at the end, what would it start with? 10, and I'd go 10, then 9. Where will I stop? At 5. So it's good to kind of think about those things and start thinking about like getting used to knowing, well, if it's 4 on the bottom, 4 and down will cancel. And you can write it all the way out if you want to, right? If that's where you're at, great, write it all the way out. But just knowing that it cancels. And then you can do this multiplication, or you can do this on your calculator. Probably is the way most people would end up doing it, right? If you were doing it all the way out like this. So 10 times 9 times 8 times 7 times 6 times 5. Or you can type into your calculator 10 factorial divided by 4 factorial. Whatever you want. You know, there's more than one option here. Okay, and I get 151,200. So he has a lot of choices. Okay, that's the answer. Now I'm going to show you how to just do this on your calculator rather than doing it. Very simple problem. That was like as basic as these problems kind of get. This is just the calculator instructions, so if you forget, it's there. You can see this is what it would look like on an older model calculator. Now, if you type in 0 factorial, and don't ask me why, because I don't know. I feel like I looked it up once, and I just can't remember. But 0 factorial is equal to 1. So if you ever end up in a situation where there is a 0 factorial, your calculator will calculate that. Like if you type 0 factorial, it'll give you 1. I can find out why if anyone's curious. Anyone? Anyone really wants to know? Okay, I'll find out for you, Leon. Okay, I will find out. I know I found out before, and I just can't remember. But it is 1, so that's just something for you to know. And other than that, it's just this way of using your calculator. I'd like everybody to be able to do it. Okay, so this is a very typical question of this unit. Like there will probably be something like this on the test using passwords or license plates or whatever. There's all these different things. So here, Tanya needs to create a password for a social networking website. The password can use any digits from 0 to 9 and or any letters of the alphabet. The password is case sensitive, so she can use both lower and uppercase letters. A password must be at least 5 characters to a maximum of 7. And each character can be used only once, which is a very unusual rule for a password, but in this math problem that's being created, it's the way. Okay, how many different passwords are possible? So here, we need to come up with, first of all, how many different characters does she have to choose from? So it's a little bit complicated because we've got a lot going on here. We have both uppercase and lowercase letters, as well as the digits 0 to 9. So how many total characters would that be? How many letters are there? 26. Aced it. Okay, there's 26 letters. Hopefully you can just memorize that. So you don't have to like sing the ABCs to yourself on a test. Okay, there's 26 of them. And we have both uppercase and lowercase. We have a choice of either. So how many is that now? 52. And then we have the digits 0 to 9. So it's going to be 62. We have 62. What's going on here? We have 62 total. Okay, that we can choose from. Now, this is also a situation where we would call this that we have different cases. What are you looking for? Yeah. Mateo.
Oh, me?
Yeah. I love you're looking at me like. Yeah. There's 62 total. Now this is a situation where we actually have different cases. We're going to see a lot of these problems. It's where we have situations where you could say, well, Tanya could have a password with 5 letters, or characters, sorry. She could have a password with, what's her other options? 6 letters, or 7 letters. Okay, so she has 3 choices. Each one of those is like a case. Okay, so she has case 1. She decides only to have 5 letters. So 5 letters, or 5 characters, I guess I should say, but imagine she has a situation where she's only picking 5 characters. She's picking the lowest number. Okay, so the equation we would use then, if we were doing NPR, N is always the total, so what would N be? 62. And she's picking 5 of them. Okay, and if we type that into a calculator, if I go 62, pick 5, okay, oops, I hit choose accidentally. Don't do what I do. Okay, I get a big number, 776 million 520,240. Okay, now that's just for 5-letter passwords. Okay, that's just the 5-letter passwords. We haven't even looked at the other choices. So if she has 6 letters, okay, so if she's going to pick 6 letters, then it would be 62, pick 6. Now, do we think this is going to be a higher number or a lower number? Higher. Makes sense, right? The bigger your password is, the more options there are. It seems like common sense. So if we pick 62 math to 6, I get even a bigger number, kind of a stupidly big number, that shows up something like this. It has this 4.42, and this is a great time to talk about this. There's all these decimals, then there's a little e and a 10 on my calculator is how it shows up. Okay? Oh, crap, sorry. I'm not, like, on the screen. Why didn't anyone tell me? When did it die? Was it, like, just a second ago? Oh, I'll just do it by hand. Okay? So I end up with this really... Here, I'll turn this off so I can do it by hand. Okay? I end up with this really weird number. Leon, can you turn on the light for me? Oh, didn't turn off either. On. Okay. Okay? We end up with this really weird number. 4.426 ... E10. Okay, so this number, just to be clear, because I'd like